All right, so let's hop into it. Guys, I'm very excited about this topic. It's a topic that we've covered very briefly in a couple of webinars in the past, but this is the first time that we delve into it in more detail. And it's titled Slipping Through the Cracks, Building Envelope Failures. So I want to just go through a few kind of quick points before we hop into it. We're going to be doing a live Q&A at the end of the webinar, so please feel free to submit your questions via the text box in the webinar screen there. We'll be trying to cover all of the questions that are submitted within the hour, but if we don't get to your question, we'll send you an email after and address it at that point. All questions are going to be addressed anonymously, and the webinar is being recorded and will be posted on our website, LinkedIn, and YouTube pages. So please feel free to pass them on to your colleagues if you think that it pertains to them. We'll also be sending completion certificates next week, mid next week. So please be patient with us. We send them out manually. At the end of the webinar, we're going to be prompting you, like once you close the actual window, we'll be prompting you to ask just a few questions. So if you don't mind answering those questions, just ranking the content and providing general feedback, that would be greatly appreciated. And if you're experiencing any technical difficulties, please email us at webinar@origin-and-cause.com. All right, let's hop into it, and I'll introduce your speaker today. So we're fortunate to have Muhtadi Sharif joining us. He is a licensed professional engineer, specialized in forensic structural investigations and the rehabilitation and restoration of existing structures. He's practiced in the analysis and design of all major structural materials, including wood, steel, concrete, and masonry. And he has comprehensive knowledge of the Canadian Building Codes, Bridge Design Code, and Blast Resistance Design Code. So without further ado, please welcome Muhtadi.
Thanks, George, for the introduction. So let's take an overview on the topics that we're going to cover today in our webinar. So first, we are going to introduce the building envelope and its components. And second topic will be discussing the types and sources of failure for building envelopes. And then we're going to cover the some types of damages that are associated with the building envelope failure. And we're going to combine the knowledge that we gathered in the first three topics and apply them into two case studies. We're going to analyze the cases together and reach the conclusion about each case. And at the end, we'll summarize what we learned, and we'll open the floor for questions at the end. So let's start with the function and components of the building envelope. So the building envelope is the outermost layer of the building, and it serves a similar role as the skin to a human body in terms of protecting the structure from the elements and regulating the indoor temperature and regulating the air movement in and out from the building. So in terms of protection from the elements, we're talking about rain and snow. We're talking about the effect of sunlight and the extreme winds, and also regulating the pressure. It also protects the building and its occupants from the harmful substances and toxins and pathogens, as well as pests. And we should not ignore the aesthetic function of a building that the building envelope is part of, as the building envelope is part of the external appearance of the building, and sometimes it has a heritage value to certain communities that must be preserved. And you can imagine how complex a claim would be if it's a historic building that would be. Now let's see what are the components of a building envelope. So we have the walls and roof and their insulation. So the insulation in the walls and the roofs are responsible for regulating the temperature and controlling the temperature movement. We also do have the damp proofing and waterproofing that's around the foundation to protect the building from the ingress of water and groundwater and moisture. We also have the moisture and vapor barriers in the walls, and we also do have our exterior finishes, such as the roofing materials, shingles, whatever. And we also do have the siding, such as brick veneer, stucco, vinyl siding. All are parts of the building envelope, including the also we should not ignore the windows and doors, and they play a major part in energy preservation, and they can be actually a weak point that would initiate the failure of a building envelope. We should also mention the soil gas control system. That's to prevent the harmful soil gases from entering into the living space. Now let's see the types of the building envelope failures. So as we mentioned, the main function of a building envelope, of the main functions are to protect the building from moisture effects, to regulate the air leakage and the thermal movement. So any failure to deliver this function is a failure of a building envelope. So we can categorize the types of failure as moisture related, air leakage related, and thermal movement related failures. Let's take a deeper look on each type of failure, and we start with the moisture related failures. Let's first view how a properly functioning building envelope would perform in protecting the building from the moisture effects. Let's consider a rainy day, and starts raining. We have the shedding action by the roof, which is protecting the interior of the building from the rain. Part of that is done by the slope of the roofs, if it's a house or a building with a sloped roof. We also have the overlapping between the layers of the roofing material that creates a watertight surface that would prevent moisture from entering into the attic space. We also do have the deflection or the protection to the siding that is done by the eave projections. And we also do have the drainage from the rain gutters and which conveys the rainwater to the grade and then to the storm management system. We also do have the site grading, where according to the code, we have to have the site graded, the site sloped away, or the ground around the building should be sloped away from the building to prevent accumulation of the water around the exterior walls. We do have also a drainage layer that, in case any water got absorbed by the soil or penetrated to the soil, now should be collected and drained to the weeping tiles and away from the building. We also have our damp proofing and waterproofing around our foundation to prevent water from entering the building. So that's a proper functioning building envelope in terms of moisture protection. Now, any failure, for example, if we have a damaged damp proofing or waterproofing, or if the side grade is sloped towards the building, now we start having problems of water accumulation and water penetration into the living space. If you have damaged shingles or damaged roof, again, we'll have water penetration into our living space. Second type of failure that we, or second category, would be the air leakage related failures. And this is usually through unsealed joints and penetrations. And basically around the windows or around the penetrations, for example, like the chimney penetration through the different layers of the building, we might start having a failure or lack of sealants or deteriorated sealants or whatever, and we'd start having air moving freely in and out, and this would lead to, of course, higher energy consumption and the ingress of toxins and car fumes. In case of an attached garage, and you have the demising wall is not sealed properly, or it has cracks or deteriorated sealants, again, would start having toxins and car fumes getting into the living space and causing people sick. The third type of failure we have is the thermal movement related failures, and this is mostly attributed to lack of insulation or insufficient insulation. And if we take the attic space here as an example, we see that during winter we have a conditioned living space that is being heated, and if our insulation is insufficient or deficient or lacking, then the laws of physics will play its role in bringing the unconditioned space to equilibrium with the conditioned space. So you start having the heat transfer from the conditioned space up to the attic. Once this takes place, we start having a warmer space here in the attic space, and then this creates a warm surface on most of the roof parts. When it snows, we start having melting of the innermost, or the first layer in contact with the roofing, and the water would move with the gravity and the slope towards the cooler regions, closer to the eave. And we start, as the water moves to that region, we start having, it would start freezing, and an ice dam is created. Now, this would trap moisture at these locations, and as water accumulates, it can actually penetrate underneath the shingles and through cracks and holes and whatever deficiencies that might be there, and then it would move into the living space and the attic space. Having this, attic space is usually dark and warm, and when we're having moisture and darkness, a little bit of elevated temperature, and plenty of food, which is the wood of the structure itself, now we start having biological growth, and microorganisms start flourishing in this environment and will cause unhealthy environment and as well as deterioration to the structure. Now that we're done with the types of the building envelope failure, let's see what causes these types of failures. So now we will discuss the sources of building envelope failure. And the sources of the building envelope failure can initiate or can start at any of the stages of the life cycle of the building. So it can start at the design stage early on. It can start at the construction stage or during the service life. So when talking about the design stage, we can talk about the incorrect detailing, for example, which is, for example, specifying in the design stage, specifying an insulation with an R value that is lower than what is required for the specific application, or specifying an incorrect roofing material for a type of slope. We can also see a missing sealant instructions, for example, in the drawings, and things like that. If went undetected or unrecognized in the first place and went to the second stage, which is the construction stage, and applied as is, would result in a failure zone, or let's say a failure initiation zone, or a weak link in the building envelope that would then, over time, would start the failure cycle of a building envelope. At the construction stage, we can see that we have mainly two main factors. The first one will be using inferior or low quality products, and this would be, if intentional, like cutting corners and getting a cheap material, or using a material that is not as specified in the design, or a material that is not approved or not according to the standards. And then this material will not, of course, perform the way that the building envelope was intended to perform as designed. So at least, or the least it would do is shorten the life cycle of the building envelope. And the worst, of course, is initiate a failure. We also have the poor workmanship. So if we have correct detailing, best design ever, and best quality materials, but workmanship that are not trained or does not follow the standards of practice or does not follow the code standards, design specifications, or the manufacturer's instructions, then we're creating a mess. You have everything like best design, best material, but assembled in a bad way. Then we start having problems and a weak spot within our structure that would again initiate a failure. During the service life, we have the action of the natural forces, such as hail, for example. Hail can damage roof shingles, can damage windows, can damage siding, and again, this would create a point of or a location where moisture and temperature would move freely in and out from the building. Also, extreme wind and soil movement both can result in separation or like breaking of sealants and separation between the different components of a building envelope. And if this separation became permanent, then we will start having a gap that allows, again, moisture and air to move freely in and out. The same effect can be done by impact, a vehicle impact or a tree impact, again, creating holes and gaps within the building envelope. And the second type of source of failure at the service life would be the lack of maintenance. So if every material in life has a certain life expectancy, and there should be periodic maintenance for the buildings, regardless of the type of the building. Periodic maintenance would prevent or would detect early on the weak spots or the points where the building envelope material or component is being deteriorated. Lack of maintenance is the opposite. You leave the building to expire, or materials to expire, to exhaust its life expectancy, and then we start having complications as a result of that. With these types or these sources of failure can occur individually, or if the building is lucky enough, then we can have a combination of 2 or more of these sources. Like, for example, you might have a low quality products that are being used and a natural force, extreme wind, and good luck for the building to sustain its integrity. So now that we explained the types and sources of failure, let's see what are the damages that are associated with the building envelope failure. To make it easy to understand and easy to digest, we can categorize them into 2 main categories. We have the direct damages and the indirect damages. So the direct damages are damages that, due to a failure in a part of the building envelope, we might have additional damages to the building envelope itself. Some sort of a self-destruction, we can say. Again, from the direct damages as well is when we see an explicit failure to deliver the function. For example, a roof that was just constructed and then a rainstorm that happened, just like right after the construction or in the early stages of the life cycle, and you see water leaking everywhere. Then this is a direct failure, easily detected, and can be directly related to a failure to a building envelope. On the other hand, the indirect damage is a slow but sure deterioration that takes place over time, and it cannot be detected in the early stages, and sometimes it's only detected when it's too late. The result of these types of damages include damage to the structure and the building components that are not part of the building envelope, and that the building envelope was supposed to protect in the first place. And the second type of damage is the creation of unhealthy environment. Think of when moisture accumulates and we start having biological growth, and these biological organisms start releasing toxins into the air, and this would create unhealthy environment and harm the occupants. As an example of the direct damage, we can consider this old building that's almost 120 years old, and we see a couple of problems here. The first one is at a certain stage, let me get the pointer here. So there was some sort of restoration that took place here, but they decided to do or build a shorter parapet at this location, and this short parapet would result in water overflow. Instead of the water goes with the slope and then moves this way and then to the rain gutter, we start having water to overflow over this parapet here. Also, we do have the flashing here, and the sealants are damaged. And another failure here is the accumulation of the tree leaves and bits of branches that block the rain gutter. And now you see all these are sources of, or these are failures to the building envelope. Now water would flow, and instead of going to the rain gutter directly, it would actually seep through these penetrations and overflow over the brick veneer. And of course, the same thing would happen here. Instead of going and being conveyed away from the building, it would just overflow and again get absorbed by the brick veneer. The problem with that being absorbed, that the water being absorbed by the brick veneer is, now we get the moisture absorbed in when it's raining or when the snow is melting. This moisture would start dissolving the salts and minerals within the brick veneer. Then when it comes to a drier day or a warmer day and the water starts evaporating from the brick veneer, it would wash out all the salts and the minerals that are an important part of the structure of the brick veneer units. And you see these salt formation, we call them efflorescence. This is a major sign that you have moisture movement in and out within the brick themselves. The problem with that is, with time, you're washing out the structure, the chemical components of the bricks, and the bricks start reducing in size, as we see here, and we start having deterioration within the mortar, and the bricks would start falling off. And the same thing happens to the concrete corbels here. We see some cracks, we see spalling, and with time, all this would fall, and we have a direct damage to part of a building envelope due to a failure in another part. One important thing to mention here also, that's a heritage building. So whatever they did with the restoration here, they restored, they used a newer material here that is not compatible with the old material. And again, this would create cracks and would put some stress on the old material that is usually weaker. So it's really important when dealing with historic buildings is to choose a heritage specialist or a historic restoration contractor. Now let's have a look at the indirect damages in more detail. So this house here, we have the balcony. This is the balcony. Okay, this image is from Google, and you see it's a concrete balcony, and we have cladding here and soffit down there, so we cannot really see the balcony itself. However, when we had a claim later that is unrelated to the balcony itself, and we had to strip the cladding out. Now we start seeing the problem that water was seeping from the surface and through penetrations and voids between between the interface between the slab and the cladding, and starts accumulating within this concealed space. The problem here is that we have these joists that are supporting this concrete slab here for the balcony, and these joists are wood. So imagine water being or accumulating in this confined space in a dark atmosphere, and plenty of food for microorganisms to flourish. And with time, we start having severe decay to a major structural support here for this balcony. So imagine how complex this claim would get just because of slowly but surely progressing sort of damage. So now that we discussed the types and sources of failure and the associated damages, we can say that we have a good amount of knowledge to analyze a couple of case studies. So let's start by the first case, which is the leaking sunroom. And this was a nice house in a farmland, and the owners decided sometime down the road to add a sunroom, which is this part here. And with adding the sunroom, they decided to do the good thing that a responsible homeowner would do, which is re-roof the house at the same time to extend the lifespan of their roof and of their house, of course. And the claim came to us as leakage at the interface between the sunroom and the main house. When I first arrived on scene, I realized that the roof slope here was shallow, and the roofing material, which was shingles, is not the code compliant material for such shallow roofs. So that was the first observation. The second thing I observed or I noticed was the chimney flashing that was not done properly. Let's start by the chimney flashing, and first let's see how a proper flashing would look like. So if we look at the image here on the right hand side, we see that we do have our step flashing that goes from underneath the shingles and up adjacent to our chimney with a distance specified by the code. And then we do have our counter flashing, which overlaps our step flashing, and it has to penetrate at a certain depth into the mortar joints. And then we apply a sealant. This way, we create a watertight surface. So when it rains, the water just goes with the flow, a natural slope, and then gets drained out away from the building. The problem that we have here is the contractor decided to just put the flashing, wrap it around the chimney, and ignore any counter flashing, ignore applying the flashing as a step flashing, and put a couple of screws here and there, and then some sealant, took the money, and called it a day. Now let's look at the roof here. When I took a closer look, again, this is the sunroom roof, and this is the main house, and that's the interface between them. First thing I noticed is the roofer did not remove the old roofing. They just re-roofed on top of it, which is not a proper thing to do. That's the first thing. The second thing is, again, we mentioned the shallow slope, and using shingles is not the proper way to do it with shallow roofs. Also, if we look at the roof profile, it goes this way, and then because of the buildup of the material here, actually, yeah, because of the buildup of the material, we start having ups and downs, especially at the interface here. So this means when it rains, water would pond here and then can actually go underneath the shingles and then into the other roof or the other space, which is the sunroom. And again, you see they framed the sunroom on top of the old shingles, which is not the proper thing to do. The restoration, the restoration contractor here in a trial to just remedy the situation temporarily, they applied some sealant at this location here so that water cannot get in and back into the sunroom space. Now, when we get into the sunroom itself, after removal of finishes, we can see that we do have a problem here. These are the old shingles here and there, and the contractor just applied the new roof on top of the old shingles. That's one point. The second thing is the roof framing itself was not done properly, so the new joists for the sunroom were supported on top of either the sheathing or on top of the fascia board, which again is not the proper thing to do in practice. So if you see at this location here is where the reported leakage was at its highest, and that's the same spot here that we have. Now let's analyze the case and see what's or apply what we learned into this case. So what are the types of failures here? We have failure to drain the water away, failure to shed because we had leakage here, so there's no shedding, and of course failure to deflect the rainwater away from the building. So what are the sources of the failure that we have? We do have poor workmanship in terms of the framing, in terms of not removing the old shingles and just re-roofing and framing on top of an existing shingles. Also, poor workmanship was visible or was obvious with the improper chimney flashing. We also had another source of failure, which was the improper detailing, and that was by using shingles on an almost flat roof or a shallow roof that is not supposed to have shingles, and this is a code or a non-code compliant practice, so that's another source of failure. The resulting damage is a direct damage, as it expressed itself explicitly as water leakage into the sunroom. So that was an explicit failure or to deliver the function that it's intended to be. And it should be mentioned that that was only 5 years after building the sunroom and re-roofing, and during a rainstorm, of course. Now let's discuss or analyze the second case we have here, which is which had a question of, was it just the wind or something else caused the loss? Again, that's nice cottage, lakefront, sweet location. And when I arrived there, the weather was awesome. That was not the case 1 week prior to my scene examination, where they had a severe wind storm in this area. And the assignment came to us as a wind damage claim. Basically, during the windstorm, the exterior wall was pushed inwards a couple of inches. Again, when you arrive at the scene, you see a couple of damages here and there. Components are dislocated, so that's common with such claims as related to wind. When we got a closer look at the exterior wall, we noticed that there is dislocation of the wall, couple of inches, especially at the location where there is a structural support at the almost midway through the wall. We also noticed we have shattered glass. So again, everything is in agreement with a structural damage due to a severe wind. We get into the building. With the finishes intact, still in place, nothing out of the ordinary. We decided to remove the finishes to inspect to see whether we have any damage to the framing or to the sill plates. And to our surprise, there was a silent killer, slowly but surely deteriorating our structural members here. So what happened is water was seeping in through this location and accumulating around the sill plate and the bearing parts of the stud posts. And we should note that on top of this stud post, we had beam that spanned all over, or that spanned through the opening, and another beam from the other side. So, and these beams are carrying the roof structure. So you can imagine if this collapsed, how bad the situation would be. Again, water was seeping in this location here, and it's a concealed space, and water and darkness, plenty of food for microorganisms and biological forms of life. And you see wood decay that takes place over time. So went undetected for years, and once the wind hit the wall, it found almost no resistance. As you can imagine, this now became almost like a piece of sponge held in place with a couple of nails. So it just moved inwards. And this structure was lucky enough that this severe wind just moved the wall a couple of inches and did not blow it out completely. So, and the reasons for the failure that we have here was, first of all, lack of maintenance, and we did not see any sealants around, or proper sealants around the windows. And again, also lack of maintenance and cleaning these sliding doors would actually block the weep holes and prevent proper drainage of water, and as such they would accumulate into the stud post location. Now, analyzing the case that we have here, we see that the types of failure we have were failure to drain and dry the rainwater away from the building. The sources of failure was mainly lack of maintenance and also poor workmanship, but that was spotted at other locations, not at this location here. The resulting damage was indirect damage to the structural components that took place over time, and it was weakening the structure. Also, a major type of damage that we experienced here was the biological growth that created an unhealthy environment in the living space. And if we didn't have this damage, but the biological growth was still ongoing, we might have failure anyways at a certain point in life, in addition to the release of harmful substance from these microorganisms that, if inhaled by humans or pets, can cause damaging health effects. Now, to conclude our webinar, we have introduced the building envelope, and we mentioned that it offers protection from the effects of the elements and the harmful substances. And we mentioned that the failures of the building envelope are often attributed to improper detailing, poor workmanship, inferior products, or low quality products. And the natural forces can also play a major part in failure of building envelope. And we should not ignore the lack of maintenance, that every building needs to be maintained and periodically to detect the flaws and the deficiencies that would take place over time, and whenever a material is deteriorated or shows sign of deterioration, should be replaced or repaired right away to prevent further failure. We mentioned that the failure can go undetected for years and would result in a slow but sure deterioration to the property. And sometimes the reported failure might not be the actual cause of the damage. And often the hidden failure of the building envelope is a major contributing factor to the loss. Now, thank you, and then time for questions.
Great, thank you so much, Motedi. So everyone, anyone that's interested in asking any questions, make sure you put them in now. We have a few minutes to answer them. All right, so first question. Sorry. So how did you determine that the deterioration was going on for several years? In, I imagine, case study 2?
This one here?
Yes.
Or the other one, yeah, like, well,
Case study 2. Did you mention that it was 2 years? Deterioration was going on for 2 years or several years?
I didn't mention 2 years specifically. I said ongoing 4 years, like, FOR. That's like,
Yes, for several years. Yes.
Yeah, for several years, right? So basically, well, decay does not happen all of a sudden. It needs time, and to determine exactly the time of, like, or exactly what, or not exactly, but to give an answer for how long this decay has been going, you have to engage an environmental engineer. But the rule of thumb is deterioration, decay to wood does not happen overnight. It takes time, and it is there, and I mean, we attended the scene within a week or two after the incident took place.
Yes. So this wouldn't have happened in that week or two.
Yeah.
Yeah. So this is definitely ongoing and repeated exposure to water. Okay, cool. Yeah. Next question. Sorry, go ahead, Motedi.
Yeah, if you allow me, George, actually.
Yes, of course.
One here, this one is definitely definitely for, like, you see how advanced decay we have here. So this cannot be, like, you cannot say this is just related to a fire claim. That's,
yes.
Yeah.
Okay. Next question. For the sunroom, what slope is needed in order for shingles to be used, and what type of roofing should have been used on the sunroom?
That's a good question here, and unfortunately, I have to look into the code to answer that question, because I do not memorize numbers. Usually, once we know things like that.
So it is variable. Yeah. Is it variable depending on its application or its region?
It's basically, it's not application. It's basically just the slope, whatever the slope is. But there are tables in the code that we refer to whenever we encounter such cases. Yeah.
And so what are the variables that would determine the slope?
Well, the situation that you have, like, for example, if you want to have a better sloped roof, for example, right, you might start, let me get the pen here. Okay. So instead of starting from this point and then just attaching it to the fascia board that contractor did here, or our situation is, you can simply attach it at a more
higher angle,
higher angle. So this way you have a higher slope, or use a proper roofing material.
So would you say, so would you say that this such a shallow slope most probably should have had like a more of a flat roof type of application?
Yes.
Okay. Okay, great. I hope that answers the question. Next question. On the sunroom roof, what is your opinion on using low slope shingles on the slope?
What is my opinion on using low slope shingles? That's a good question as well. I mean, if the low slope shingles are code compliant, then there's no problem. If it's non-code compliant, then there's a problem. So we have to first of all see the material and whether it meets the code standards or not.
Okay, great. So in the example of the roof with the parapet that failed was or not installed properly, can you demonstrate how it should have been installed to function properly? So you kind of just went through that, right?
Yeah. So I mean, I had a better image, but I don't have it here. But let me try to illustrate here the situation. So you see this height here, that was everywhere. Like this type, this parapet here, part of the parapet. This height was maintained everywhere in the roof. I do not have the full image with me now, but here the person who did the repair for this part, they just decided to stop it here without. So this parapet here should have had a little bit of a height at this location, so that it prevents the water from overflowing it. And unfortunately, but I had a full image where the other side of the wall of the exterior wall was not repaired, so the original state was there, and this parapet here was higher. The original parapet was higher than this one. So hope this answered the question.
Great, thank you.
Thanks.
For the wind damaged building, was the additional weight of the roof structure, or did the additional weight of the roof structure contribute to the wind failure? And do you check to see if a building permit was issued for the roof structure?
That's a good, if you're talking about this one here, that's a good, really good question, because you can see that there are lots of additions and alterations that are not native to the original building. Well, this type of failure, I wouldn't say any additional load on the roof would cause it, because this was a pushover kind of failure where, you know, it was pushed this way. So if the, and of course that's not to be taken generally, it's a case specific, but you know, in general, in engineering sense would say that if this is being pushed, let me get the pen here. If this was getting pushed this way, right, and you have a weight on top of it, you know, that would stabilize it a little bit from being pushed, not making it worse. Of course, other factors would be taken into place, the height of the wall and stuff like that. But I wouldn't say that the weight would contribute to that failure. If any, it would have actually stabilized it. But again, it's not support, like this additional part of the roof is not supported on this beam here. It's supported somewhere here, which is, again, would not affect this wall much. Yeah.
Great. Next question. If in the claim outside air was entering into the building for a month through opened windows in peak winter time, freezing outside temperatures, what kinds of damages are possible inside the building envelope?
That's
So,
an open-ended question.
so yeah, so it's like, if, you know, what could you expect to be the damages if a window was cracked open?
I mean, winter freezing times.
Yes.
I would imagine. Actually, I mean, if the pipes are not shut, then you might have water damage, flooding, right? I mean, pipes might freeze. But in terms of building envelope failure, that's
So yeah,
I
and
need
I
to look
imagine,
into that. I'm not sure.
yeah. So without the potential of water infiltration, which is highly probable, is there any other building envelope concerns that you would have with the window being open, like not relating to the obvious water coming in? Like extreme cold temperatures inside a building.
Well, again, it has to be case specific to consider this hypothesis. That, I mean, there has to be a case that we can consider whether freezing temperatures would have caused certain damage. But
Sure.
yeah, to list possible damages, I guess is a bit difficult.
Yes. Later on, it stated we have some condensation marks outside the drywall, but not sure what's behind the drywall. I think what we could do is send an email to this person that submitted this question, and we can kind of find out more information.
Yeah.
Great. So that concludes our webinar. Thank you so much for joining us today, and thank you so much, Motedi, for your presentation. We will be sending completion certificates mid next week. If you have any questions or anything leading up to that time, you could email us at webinar@origin-and-cause.com. Thank you again, everyone. Stay safe and have a great day.